Hey everybody, it's Mrs. C and I am coming to you today with a Let's Solve video. So I've had a lot of requests from students saying, can you please just make a video where you do some practice and maybe not talk quite as much. That would be probably the end of the world if you actually heard me doing a video where I was and not talking. It doesn't happen. But anyway, yes, of course I can do a video where we just practice. So I'm putting up some problems. You can see our Let's Solve video today is on absolute value. I hope you can see that. And so let's just get started. That's the whole point, right? Just jump right in. Now, I have several problems. I'm just going to pick one right now and clear the board so we can just start practicing. So let me pick one. Okay, so I picked one. I cleared the board. Probably should have warned you that I was about to do that. And here it is, number 13, lucky number 13. And then as I was about to get ready to record, I realized that is really, really small. So let me just rewrite that. It is a 5 minus 8 touching the absolute value. So how do we call that? It's 5 minus 8 times the absolute value of a negative 2n. Close those bars, set it equal to a negative 75. Now here's where a lot of you say, oh my gosh, it's equal to a negative and I know absolute value. I'm just practicing and it can't be equal to a negative, so this must be no solution. No, my friend, that is only if what you see on the other side of the negative is the absolute value bars alone. And right now we can see it's times by a negative 8, and then we are also adding a positive 5 to that side. I know you're saying we're subtracting it. No, we're multiplying by a negative 8, and we are adding a 5. That's a lot of arrows. So what, basically, in general, what I'm saying is we got stuff to do before we can decide if it's a no solution or not. So let's get it started. Where do I start? Well, I want to start with the side with the absolute value bars, and I want to get rid of the outermost thing. So usually in algebra that means, if you can, add and subtract first, multiply and divide last. It's a good rule of thumb, so always try it. When you first start out a problem, you always want to combine like terms, yes. That aside, when you're trying to move things back and forth, we call that transposing. When you want to transpose, you want to start with addition, subtraction, and end with multiplication and division. It usually creates the least path of resistance, and so it's a good place to start if you're not sure. So which of these, let me put a positive in front of that one, which of these two guys here are adding and subtracting? Well, it would be this one. This one over here is multiplying to the absolute value bar. That's why I said a negative 8 times or minus 8 times the absolute value. And I want to start with addition, subtraction. So how can I remove a positive 5 from this side who's minus by 8? Well, I can just minus 5. Here we go. All right. So that's going to leave me with a negative 8 times the absolute value of a negative 2n equal to a negative 75 and a negative 5, or a negative 75 minus 5. What's our rule? When these signs are the same, you find the sum. It's going to be an 80, and you keep the sign. That would be negative. Still can't decide if it's a no solution because I have this negative 8 on the left side to deal with. So how do I get rid of a negative 8 timesing? I divide by a negative 8. Dividing both sides by a negative 8, those negative 8s cancel out, leaving me with the absolute value of a negative 2n equal to, now a negative divided by a negative is positive. 80 divided by 8 is 10. So what I have now is an opportunity to judge this absolute value to decide how many solutions I have. So hang on a second, let me just move over, move up. One quick second, making room. Okay, I just erased some of the extra process so that we could focus in on this. When I have an absolute value set equal to a number, I can make several judgments on it. I can decide right now, because this bar is completely by itself, I can decide several things based on what that number is. I can decide if I have one solution, if I'm going to have two solutions, or if I'm going to have no solutions. So the no solution clearly would be if it was equal to 0. And I'm going over this like you know it, because if I don't have a video on solution intuition for absolute values, there will be. But right now, here's the skinny. If this number, this 10, is had been equal to a negative, that would have been your no solution. If it had been equal to 0, that would have only given you one solution. If it's equal to a positive number, that excludes 0 and the negatives, so that's everything else, it will give me two solutions. So in this case, you see 10 is positive. I'm going to have two solutions. And so let's find out what those two solutions are. At this point, I always tell you, break open those absolute value bars, right? And set it equal, negative 2n equal to the 10, and the negative 2n equal to the negative 10. I have another video that's just on intuition. Why did I just do that? Why did I set 1 equal to itself and then to the negative version? Watch that video if you're confused. Dividing both sides by the negative 2, that's going to give me n equal to negative 5. Apologies for the sloppy. I'm out of room. Then over here, dividing by a negative 2, that's going to give me, up here, n is equal to positive 5. Are the answers always the positive and negative version of themselves? No. That's just happened in this case. Now, a quick check step is always to store that value into your calculator and check that this side is equal to this side. But in my case, I have an answer key, so it makes it a little bit easier for me to double check that the answer is truly n equal to negative 5, n is equal to positive 5. Let's try another one. All right, let's try this one. I copied this one from that sheet, and let's get started. We have 3 minus the absolute value of 8x minus 6 equals 3. Again, now, guys, I know you've heard this probably 1,000 times, but let's make it 1,001. When you have a negative touching a symbol, touching parentheses, touching absolute value bars, you can squeeze in a little 1 there to make it easier for you to identify what needs to be done to give you the opposite of what you're looking at. So we have really a 3 minus 1 times the absolute value. And you know when you times by 1, it's really not doing much, but sometimes it just makes people feel a little bit better. So I just put that bar down. Can I judge over here how many solutions I'm going to have? No. And the reason is, that's right, I can't make that decision till the left side is clear of everything except the absolute value bar. Usually the left, it could be on the right, doesn't matter. So let's start with the outermost. Let's start with the addition, subtraction. Let me, again, opposite operation here is minusing 3 from both sides. That's going to leave me with a negative 1 times the absolute value of 8x minus 6 equal to 3 minus 3, 0. Oh, I'm just making a little note. Not done yet, though. I want to get that negative 1 off, so I want to divide both sides by a negative 1. Some of you out there are going, why are you bothering? No, because it's the process, and I want to I want to do everything properly. I'm supposed to divide by whatever's touching. In this case, those of you watching it wondering why I'm doing it, know that 0 divided by any number is 0, and so I'm still left with 0. And that's an awesome situation because this is an example of what we talked about in the last problem. Make the call now. Do I have one solution, two solutions, or no solution? Don't tell me no solution. Just because it's a 0. Why do people judge 0 like that? The only way this is a no solution is if it was a negative number, and it's not. When you have a 0, you are going to have one solution only, and watch why. When you blow these absolute value bars away and do your process where you set them first equal to itself, and then you come over here and you set it equal to its negative self. What the heck is the negative version of 0? There is no negative 0. Please don't put it. There is no negative 0. And even if you put negative 0, wouldn't matter because you'd still probably wind up doing it and getting the same answer. There is no other option. You have 8x minus 6 equals 0. There's no other way to write it. You would get the same answer if you did. And then that means all you got to do is the one problem, which is why when the absolute value bars are set equal to 0, you have one solution only. And in this case, looks like I'm always running out of space, aren't I? In this case, it looks like I'm going to have, I'm writing it over here, 8x, equal to 6. Divide both sides. We get x is equal to 2/3. 6/8. Did I say 2/3? 2 into that 3, 2 into that 4. 3/4 is what I meant. Oh my goodness. What time is it? X is equal to 3/4. Awesome. Man, we've done an example of one solution. We've had 2 solutions. I wonder if the next one might be no solution. Okay, I have another one. I have copied it so the writing's not so small. We have a -4 minus 2 times the absolute value of x plus 3. And that is equal to 20. So let's just divide that side. And a lot of people wonder, why do you put that big line, especially, my gosh, with the absolute value bars, it gets a little confusing. I agree. The reason I do that is to keep the sides separated so that you always know whatever you're doing to one side, please make sure you go over to the other line, the other side of the line, and do the opposite there. Some people get confused and they do the opposite to the same side. They'll add 4 and then they'll add 4 to the same side, and that just screws you up completely. So let's get started. We want to, these all kind of looking the same. I think that's nice when you're practicing just to get a handle on what's going on. We have a -4 minus 2. So which do we do first? It's a -2 or -2 times. So I want to add this time. That's nice. I'm adding instead of been subtracting every time I've done this. All right, every time is twice, but whatever. A -4 and a +4 canceling out, leaving me a -2 times the absolute value of x plus 3 equal to what's going on over here. I got a 24 now. All right, next step, I want to divide both sides by a -2. Dog barking. Really, Bella? Really, Bella? In the middle of a video here. Knock it off. Left with the absolute value of x plus 3 equal to 24 divided by -2 is a -12. Oh boy, look at what we got here. Make the call, guys. Absolute value on the left. Totally isolated. And thank you, Bella. I know. I'm excited about it too. Look at it. Look at it. Look what we have. It's equal to a negative. What does that mean? It means you can't have an absolute value equal to a negative. Because whatever this is, whatever x is equal to, it's going to come out and be positive, which means it can never be equal to. No positive anything will be equal to a -12. This, my dear friends, is a no solution. Here I was equal to a negative. So if you could just remember, and I wanted to keep this video short, if you could just remember the 3 things. When the absolute value, whatever's in here, when your absolute value is equal to a negative, when your absolute value is equal to 0, or when your absolute value is equal to a positive, you have 3 different things that will happen as far as solutions. So let's just write that down. Picking color, picking color, picking color. What haven't I done yet? I know it doesn't matter. I've done them all. Pink. Okay. When your absolute value is equal to a negative, what was it? That's right. It's a no solution. When it's equal to 0, how many solutions do you have? You have 1 solution. Equal to a positive, 2 solutions. You'll know that every single time. And in future videos, we're actually going to do some graphing to see what that actually looks like and why. So say the absolute value of x and it was equal to a negative, no solution. The absolute value of x equal to a 0, you'll have one solution. And the absolute value equal to a positive number, you're going to have two different answers. All right, guys, I hope this video helped you out, helped you practice a little bit. And if you are seeking practice, I just want to share with you, of course, as always, your CUDA software. CUDAsoftware.com has a free worksheets section. And hold on, because I know I've said this before, but I'm trying to tell you something. Word and talk at the same. Spell and talk. Free worksheets. Those are actually 3 separate words. Where's worksheets 1? Okay, good thing I'm a math teacher. CUDA software has a free worksheet section, and these actually came off of the Algebra 2 option. So don't forget, guys, if you're in Algebra 1, look at the Algebra 2 section, because a lot of the stuff they do is no harder than what we do. And Algebra 2 peeps, don't feel like you're downgrading yourself. Go over to the Algebra 1. That's where we learn all our basic skills. So, you know, Algebra 1, Algebra 2, for the most part, the basic stuff is the same. So you have 2 places to go to get awesome practice with answers. Remember, always check your answers. And what else you need to remember? You know what it is. See you on the flip side. Peace.